Okay, today we have our lesson 5.2 video, which is all about polynomials. A polynomial is going to be the sum of one or more monomials, both having the nomials word in them. Mono, again, just meaning one. Poly, meaning many. So a polynomial is just a combination of one or many monomials. Now, things that a polynomial is not is anytime that an expression has fractional exponents, such as x to the 1/2 or y to the 1/3. These are not polynomials. So we need to watch out for that as well. Anytime that there are square root of variables, so like the square root of x or 3 square roots of y, these are not polynomials because they have those square root of the variables inside there. Also, anytime that we have a numerator that has a negative exponent. So let's say we had x to the -2 over 2. This is not going to be a polynomial because of the negative exponent that is present there. Similarly, anytime the denominator, the one on bottom, has a positive exponent. So if we had 3 over b to the 4th power, this is not a polynomial because it has the positive exponent there. So now that we've kind of discussed what polynomials are and what they are not, we also need to look at the degrees of a polynomial. Now, anytime you have a polynomial, each term will probably have or should have variables to different exponents or to different powers. Now, the degree of each term is going to be just the sum of all of those powers. So then in the end, the degree of the polynomial is the highest of these degrees of each of the terms. I'll show you what I mean with our examples here. So first in our examples, we need to determine whether each expression is a polynomial or not. And if it is a polynomial, we'll state the degree. Well, in our first one, our polynomial is c to the 4th power minus 4 square root of c plus 18. Now in this case, we have 4 square roots of c, or should I say -4 square roots of c. And because we have the square root of a variable, we know that this one is not a polynomial. So if you came up to one on this, like on a homework problem, you would just say not a polynomial. Because it does have that, the square root of a variable inside there. Now moving on to the other one. This polynomial is -16 p to the 5th power plus 3/4 p squared q to the 7th power. So this one has two terms, the -16 p to the 5th and the 3/4 p squared q to the 7th. And it follows all of our rules. None of the fractions are exponents. There's no square roots of any variables. There is no numerator here. It's all just one piece. And so the denominator doesn't have any positive exponents, and the numerator doesn't have any negative exponents. So this one passes, and it is a polynomial. So again, on one like this, you start by saying is a polynomial, and then we need to look at the degree of each term. So we look at our first term here, the -16 p to the 5th. We notice that it only has the one exponent, that's 5. So this is of degree 5. When we look at our second term here, we look at our variables and they have exponent of p to the 2 and q to the 7th. So 2 plus 7 gives us a degree of 9 for this term. So the degree of the whole polynomial would just be the higher of these two, which as we can see is 9. 9 is higher than 5, so we'd say is a polynomial, and it's of degree 9. Moving along then, if we want to subtract and simplify polynomials, here we're given two trinomials. Trinomial is a polynomial that has 3 terms, so we are subtracting and simplifying these two trinomials. Anytime that we have a subtraction of a polynomial, we know that that's the same as saying adding the opposite. So if we wanted to rewrite this one, actually I'll take these away. If we wanted to rewrite this one, we would say 2a cubed plus 5a minus 7. Now again, subtraction means adding the opposite. So it'd be like adding the opposite. So adding a negative 1 times a cubed minus 3a plus 2. Because again, subtraction means adding the opposite. Now this helps us a lot here because we can see that now that we have this negative 1, we have to distribute that to each of our terms before we can add anything. So our next move then is to keep this trinomial the same, but then we need to distribute the negative to all of these. So we have, or should I say distribute the negative 1. So we have negative a cubed. Negative 1 times negative 3a gives us a positive 3a. And negative 1 times positive 2, whoops, that should be a negative 2. Now that we have our polynomials in this form, we need to look at all of the terms individually. So we have our a cubed terms, our a terms, and our constant terms. So the first ones we look at are the a cubed terms. We see that we have 2a cubed minus 1a cubed, or just minus a cubed. Next ones we look at are our 5a plus 3a. And then we look at our constants. We have negative 7 minus 2. We're not finished at this point because we still need to combine our like terms and simplify down. So 2a cubed minus 1a cubed would leave us with just 1a cubed, or we can just say a cubed. Our 5a and our 3a add together to become 8a. And our negative 7 minus 2 subtract to become negative 9. So in the end, our simplified answer is going to be a cubed plus 8a minus 9. Moving right along, multiplying and simplifying our polynomials. Anytime that we have a polynomial, in this case our trinomial, being multiplied by just a single term out front, we need to use that term and distribute it to each term on the inside of our polynomial. So to do that, in this case, our 4y squared times negative y is going to give us a negative 4y cubed, because this is y to the 1 and y to the 2, and 1 plus 2 is 3, so that is y cubed. Moving right along, negative y times positive 2y is going to leave us a negative 2y squared. Again, because this one is y to the first power, and this is y to the first. 1 plus 1 is 2. And our last piece, we have negative y times negative 3. Negative times negative is positive, so this becomes a positive 3y. Now all of these are in terms of y in different degrees, so these terms are already simplified down. So this is our final answer for the polynomial. Moving on to our second example, again we have negative 2x, which needs to be distributed to each term of this trinomial. So when we distribute it to the first one, 2x times 7x squared becomes 14x cubed. When you distribute it to our second piece here, 2x times negative 3x becomes negative 6x squared. And distributing it to our last piece, 2x plus 5x, or 2x times positive 5x becomes positive 10x. Again, each of these is in the, they're all in x, but this one is x to the first power, x to the second power, and x to the third power. So there are no like terms, so this is already simplified down. Moving right along to multiplying two binomials. Each of these is a binomial because it's a polynomial, just 1, 2, and 1, 2 terms. Anytime that we are multiplying two binomials, we will use the FOIL method. The FOIL method is just a method for multiplying polynomials, only the binomials, in which you multiply the first ones. So these are the first ones. The outer ones, this is outside, this is outside. The inner ones, this is an inside, this is an inside. And the last terms, this is a last term, this is a last term. So we just need to make sure that we do those in that order, first, outer, inner, last, and combine everything to simplify it down. So, starting with this, our first one is to do the first. So 2p and 4p, which multiply to 8p squared. The next one that we want to do would be our outer pieces, 2p and 1. 2p times 1 gives us a 2p. The next piece we want to do is the inner, 3 and 4p. 3 times 4p is going to be 12p. And again, our last ones are the last, 3 and 1. 3 times 1 just leaves us with 3. Now looking at this, we have two different terms that are in terms of p. P to the first power, so those are the ones we need to combine. So we leave our 8p squared as it is. 2p plus 12p is going to give us 14p plus the 3 constant at the end. So in the end, our polynomial sums up to, or multiplies out to 8p squared plus 14p plus 3. Foiling out this second one, if we want to do our first, 5x and 5x become 25x squared. If we want to do our outer, that would be 5x and negative 4w. Remember, it has that negative out in front of it, so we need to do negative 20xw. Now if we do our inners, it's going to be 4w and 5x. That's going to give us a positive 20xw. And moving on to our last, 4w and negative 4w gives us negative 16x, oops, not xw, there's no x in that one. That one is just negative 16w squared. Now again, from here, two terms have the xw as their variable, or their term. So those are the ones we need to combine. Our 25x squared stays as it is. The negative 20xw and the positive 20xw, those add together to make 0, so we can just get rid of those. That'd be, in the end, 0xw, so it's not necessarily right that. And then we're just left with negative 16w squared. So our simplified version of this polynomial is going to be 25x squared minus 16w squared. Moving along to our last example for the binomials, when we have a binomial, 2x minus 9 squared, this is not going to be the same as when we have our monomial squared. When we had the monomial squared, we would just take our exponent and we would apply it to each of our pieces individually, which in this case would have left us with 4x squared plus 81, because each of these pieces would have been squared. I'm going to tell you that that is not the case on this one. When we have, when we are squaring a binomial, we need to make sure that we put it in a FOILable form. So when we square something, that's the same as saying take your binomial and multiply it by itself. So we'd have to write 2x minus 9 times 2x minus 9. Now from here, we can FOIL it out and say our first ones, 2x and 2x, multiply together to become 4x squared. Then we take our outer, so 2x and negative 9, leaves us with negative 18x. Then our inner, our negative 9 and 2x, gives us another negative 18x. And now our last, that would be negative 9 and negative 9, gives us a positive 81. From here, two of our terms are just in terms of x, so we have to combine those ones. So in the end, we are left with 4x squared minus 36x, so we have the negative 18 and the negative 18, that subtracts to negative 36x plus 81. Now remember, like I said, if we just took the second power of the squared and applied it to each of those individually, that would have left us with 4x plus 81, but we would have missed the negative 36x part. So we need to make sure to always FOIL whenever we're using binomials. Moving on to multiplying polynomials. This is going to be similar to our FOILable format, only FOIL only works when it's binomials. When we're multiplying polynomials that are in terms that are bigger than binomials, so there's more than those two pieces, it's going to be similar in the sense that we're distributing each piece to each other piece. So in this case, we would have to distribute the a to each of our other terms, so a to the negative 4, a to this 3a, and a to this a squared. And we would have to distribute the 2 to our negative 4, our positive 3, or positive 3a, and our a squared. So there's going to be 6 pieces, whereas our FOIL just gave us 4, and then we simplified it down. So if we start with a and a squared, that's going to give us a cubed. And if we do a to 3a, that's going to give us positive 3a squared. And if we do a to negative 4, that's going to give us negative 4a. So now we've done all of them with the a. Now we need to go on to 2. So if we have 2 times a squared, it's going to give us positive 2a squared. 2 times 3a, that's going to give us positive 6a. And 2 times negative 4 is going to give us negative 8. Now from here, again, we need to combine terms. Our a cubed is the only one of its kind. Our 3a squared and our 2a squared can get combined, and our negative 4a and positive 6a can get combined. Negative 8 is the only constant we have. So once we find how to combine all of these, we just rewrite them out. So all of our a cubed terms are there, so just the a cubed. Now we need to put all of our a squared terms together, so 3a squared and 2a squared adds up to a 5a squared. So that were our a squared ones. Our negative 4a and our positive 6a, those add up to a positive 2a. And we still have our constant, is that negative 8. So in the end, our answer is just going to be a cubed plus 5a squared plus 2a minus 8. In the same way, if we look at this next one, again, we have a binomial being multiplied by a trinomial. We just need to remember to distribute each one individually. So our x to the x squared, x to negative 3xy, and x to the positive 2y squared, and the y to each of those individually. So if we start out by doing the x to the x squared gives us an x cubed. X to the negative 3xy gives us a negative 3x squared y, because of our two different x's being multiplied. And our x to our positive 2y is a positive 2xy squared. So that was the first part of that. Now we need to look at all of our y's. So if we have y times x squared, I'm actually going to move this over some. So if we have y times x squared is going to give us plus, well, I'll write x's first, so plus x squared y. Y times negative 3xy gives us a negative 3xy squared. And y times positive 2y squared gives us a positive 2y cubed. Now again, we're not finished until we have all of these ones simplified down by combining all the like terms. So here we see is all of our x cubed terms, so we can just write x cubed is all alone there. Here we have an x squared y term and an x squared y term, so we need to combine those. We have a negative 3x squared y and a positive 1 x squared y, so that becomes negative 2 x squared y. Moving on, we see that we have our xy squared term and our xy squared term. This one is a positive 2, this is a negative 3. So we add those together to get a minus 1, or just negative xy squared is our third term. And we just have one of our y cubed terms. So in the end, that just becomes positive 2y cubed. Oops, that's a cubed, not squared. So in the end, after adding them together and simplifying down, our answer is x cubed minus 2x squared y minus xy squared plus 2y cubed.